Space exploration captivates our imagination. It fuels our dreams of reaching distant stars and unraveling the cosmos mysteries. We yearn to explore the unknown. We are driven by a thirst for discovery. For decades, chemical rockets have been the workhorse of space travel. They have propelled us to the moon and beyond. But chemical rockets have limitations. They are inefficient. They require a large amount of fuel. Enter ion propulsion, a revolutionary technology that promises to transform space exploration. Ion engines offer a more efficient and sustainable way to travel through the cosmos. They could be the key to unlocking the secrets of our solar system and beyond. Imagine a future where spacecraft silently glide through space. They would be powered by the gentle push of ionized gas. This future is closer than we think. Ion propulsion is no longer science fiction. It is rapidly becoming a reality. Let us embark on a journey to understand this game-changing technology. What exactly are ion propulsion systems? Put simply, they are engines that generate thrust by accelerating ions. An ion is an atom or molecule that has an electrical charge. This charge is created by adding or removing electrons. Here's how ion engines work. First, ionization. A neutral gas, typically xenon, is bombarded with electrons. This process strips electrons from the gas atoms, creating positively charged ions. Second, acceleration. The ions are then accelerated by an electric field. This field is created by two grids with a voltage difference between them. Third, neutralization. As the ions exit the engine, they pass through a neutralizer. This injects electrons back into the ion beam, neutralizing the charge and preventing the spacecraft from becoming electrically charged. This process of ionization, acceleration, and neutralization generates a small but continuous thrust. It propels the spacecraft forward. Unlike chemical rockets that produce short bursts of intense thrust, ion engines provide a gentle, continuous acceleration. To appreciate the revolutionary nature of ion propulsion, we must compare it to its predecessor, chemical rockets. Chemical rockets work by burning a mixture of fuel and oxidizer. This combustion produces hot gas that expands rapidly, creating thrust. While effective for launching spacecraft into orbit, chemical rockets are inefficient for long-duration spaceflight. They require a massive amount of fuel, which adds weight and cost to missions. Ion engines, on the other hand, are far more fuel efficient. Think of it this way. Imagine you have two cars, one with a large gas tank and the other with a small but highly efficient engine. The car with the large gas tank may be powerful at first, but it will quickly run out of fuel. The car with the efficient engine, however, can travel much farther on the same amount of fuel. Ion engines are like the car with the efficient engine. They use a tiny amount of propellant, but they can accelerate for months or even years. This makes them ideal for deep space missions where efficiency is paramount. Section Efficiency and Sustainability, the advantages of ion propulsion. The efficiency of ion propulsion translates into several tangible benefits for space exploration. First, ion engines can operate for extended periods, allowing spacecraft to reach distant destinations that would be impractical or impossible for chemical rockets. Second, with less fuel needed, spacecraft can carry more scientific instruments, supplies, and even humans. Third, while ion engines are expensive to develop, their fuel efficiency can lead to significant cost savings over the lifespan of a mission. And finally, ion engines use inert gases like xenon, which are non-toxic and have minimal environmental impact. These advantages make ion propulsion a game-changer for the future of space travel. As we venture farther into the cosmos, we need sustainable and efficient technologies. Ion propulsion offers a glimpse into that future. Ion engines and the journey to Mars. Perhaps the most exciting prospect of ion propulsion is its potential to enable human missions to Mars. The Red Planet has beckoned humanity for decades. It represents the next giant leap in our exploration of the solar system. While chemical rockets could be used to send humans to Mars, the journey would be long and arduous. Ion engines, with their sustained acceleration, could significantly shorten the travel time. This would reduce the risks associated with prolonged spaceflight, such as radiation exposure and psychological stress. Moreover, ion engines' fuel efficiency would allow for larger payloads to be transported to Mars. This means we could establish a more substantial human presence on the planet, with all the necessary equipment and supplies for long-term habitation. The journey to Mars is fraught with challenges, but ion propulsion offers a beacon of hope. It brings us one step closer to turning the dream of becoming a multi-planetary species into a reality.